We're asked in the following examples to find any vertical asymptotes. So I have a hint here, and it says just set the denominator equal to 0 to find the vertical asymptotes. Well, this is actually really easy. So all we do in this rational expression, or this rational function, is take the denominator, and in this case it's x minus 1, and we set it equal to 0, and then we solve for x. So this is all we have to do. So we get x equals 1. So the vertical asymptote here is at x equals 1. Now let's think about this for a second. Why would the vertical asymptote be at x equals 1? Well, what happens when x equals 1? You would get 0 in the denominator. And consider the fact that you cannot divide by 0. Therefore, this creates an issue. That's why we have what's called vertical asymptotes. So an asymptote, if you've seen a graph, it might look something along the lines of something like this. So it just grazes, that vertical line, wherever it may be. So it doesn't actually touch this vertical line, in this case the vertical axis. So that's where that's what a vertical asymptote is. It's this kind of dotted line, this vertical line, if you will. All right. So now let's take a look at this next example. All right, we have another rational function, and again, the numerator is not really important to us, but the denominator is. What we do is set the denominator equal to 0. Now, you should recognize that this right here is what we call a difference of two squares, or dots as I call it. So it's a difference of two squares, so we're going to take x plus 3 and multiply it by x minus 3. We set it equal to 0. Now we apply the zero factor property, and x equal -3 and x equal +3. So this one right here actually has two vertical asymptotes. All right, so this one has two vertical asymptotes, and we simply write them out just like this. The vertical asymptote at x equals -3 and +3. So here's just a little bit of information on how to actually find vertical asymptotes for rational graphs of rational functions.